Hello, good day class. Welcome to today's class. Our subject for today is basic science, and the topic for today is energy. For today's class, we are going to focus on an aspect of energy, which is force. What is force? Force is simply a push or a pull on an object or surface. Alright. What are the types of force? One, we have the contact force, and the second one is the non-contact force. The contact force requires a physical interaction or a physical touch between the objects that are experiencing the force. Examples of the contact force is the friction force and the push, pull, and tension. Now, we've experienced friction when we rub our hands together. We've also experienced a push or a pull by someone before now. Then what about tension? When you are trying to tear two things apart, like when you have a rope and you're trying to pull the rope in two different directions, you see something tends to tear the rope into two. And that force is what we call tension. Now, the next part is the non-contact force. That means this force does not require a touch. We don't need to touch the surfaces that are expressing these forces. Example of the non-contact force is the gravitational force, the electric field force, and the magnetic force. Now, we call these three types of forces, that is non-contact force, we call them what? Field forces. That's another name for non-contact forces is field forces. Now, for the gravity, let's take them and let's explain them one after the other. Let's speak of gravitational force. What is gravitational force? It simply means the force of gravity. That means the force exerted by the Earth's surface on everybody around it. In simple terms, it simply is that force that tries to pull every object towards the center of the Earth. Mathematically, we can represent it with a formula. Fg is equal to PE, and it's also the same thing or equal to mgh. What is Fg? Force of gravity, that is gravitational force, Fg. Now, PE means potential energy. That means energy possessed by a body due to its relative height. And also, potential energy can also be related to mass of the body. That is mass of the body m times the acceleration due to gravity, g. It's a constant. It doesn't change. It's always known to have a particular value. And that value is 9.8 or approximately 10 Newton per meter squared. Just like your pi is 22/7. G is 10 Newton per meter squared. And your h is the height of that body. So, force of gravity is equal to mgh. Now, Fg, just like we've explained, we've already explained all this. This is just like the definition of the formula I have stated above. That means Fg is equal to mgh. Now, let's look at a way we can use this to solve a problem. Please, this is m. It's measured, all right, in meters. All right, let's go over to one example. That is an exercise we want to solve. Just to use this formula and see how we can calculate the force of gravity acting on any body. Let's look at this. Wisdom has a mass of 48 kilograms. What is the force of gravity on him at a height of 12 meters above the ground level? Solution. Our force of gravity, which we are asked, is Fg, is equal to mass of that body times the gravity, which is g, times the h. Simply put, Fg is equal to mgh. Alright, now our Mg is what we are looking for, and our mass was given to us as 48 kilograms. That is from the question. Alright, we bring out the information we need from the question. Now we also have our gravity G to be what? 10 newtons per meter squared. This is how we write it, minus 1. Nm raised to the power minus 1. Or we can rewrite it as 10 n per m raised to the power 2. Like this or like this. Both of them is what? Acceptable. Now let's look at our height. Our height was given to us as what? 12 meters. Alright? So when we incorporate all this information into this formula, we get that Fg, which is the force of gravity, is equal to m, which is 48, times the gravity, which is 10, times the height, which is what? 12 in meters. Alright, we are eliminating the unit, we don't need them here. Now we can multiply 4 times 48 times 10 is 480. Then 480 times 12, which we can multiply out in our 480 times 12. Will give us 0, 6, that's 2 times 8 is 16. We carry off 1, with the carry off 1, 2 times 4 is 8 plus 1, 9. Alright, now we have 480. That is 1 times 0, 1 times 8, and 1 times 4. So we'll add everything together. We have 0, we have 6, we have 8 plus 9 is 17, right? So I can carry 1 as 5. Alright, so we have 5760. That means our force of gravity is equal to 5,760 newtons. Force is measured in what? Newton. That means the standard international unit. Standard international unit of force is newtons. It is named after the scientist called Isaac Newton. Alright? After what? Isaac what? Newton is a scientist that his study was basically on mathematics and science generally. Alright? So that is it for today's class. When next week when we continue with our other non-contact forces, that is the electrical forces and the magnetic forces. Alright, so thank you and have a nice day. See you next time. Bye.